Here we have a multiple choice question on AP Calculus AB. Okay, let's go with the information. If limit x approaches a, f of x equals to L, where L is a real number, which of the following must be true? We have three statements over here. Okay, so before we start solving this question, first let's understand the types of limits. So there are three types of limits. One is the left side limit, and the second one is the right side limit, and the third one is ordinary limit. First, let me write the left side limit. That is limit x approaches a from its left side, f of x. And the second one is limit x approaches a from its right side, f of x. And the ordinary limit, limit x approaches a, f of x. Okay, here, so when I consider the first limit over here, x approaches a, and there is a negative sign on the right side top corner of a. So whenever there is a negative sign over here in the limit of the variable x, so it's called left side limit. That is x approaches a from its left side. For example, let me mark a on the real number line. So here x approaches a from its left side because its negative sign indicates left side limit. That means x approaches a, x is getting closer and closer to a from its left side. And here when I consider the second limit, there is a positive sign on the right side top corner of a. That means x approaches a from its right side. So here the first one, since x approaches a from its left side, it's called left side limit. So to indicate this one is left side limit, we write negative sign over here. And since x approaches a from its right side over here in the second case, it's called right side limit. To indicate right side limit, we write positive sign over here. But when you go to the third one, we don't have negative sign or positive sign over here. So we just have a. So this is called ordinary limit. So for example, let's consider the result of the left side limit equals to L, and say L is a real number. And let's say the result of the right side limit also L, it's a real number. So here both left side limit and right side limit of the given function f of x equal to the same real number L. Then ordinary limit also equal to the same real number L. And here we have a question. For example, I don't get the same real value for the left side limit and right side limit. What about the ordinary limit? So then what we have to do is we have to say the ordinary limit does not exist. If the left side limit and right side limit are not equal, we have to say that the ordinary limit does not exist. But here I say that left side limit equals to the real number L, the right side limit also equals to the same real number L, then the ordinary limit exists, and that one also equals to the same real number L. Okay, so now it's clear. Statement 2 is correct. Statement 3 is also correct because the ordinary limit x approaches a for f of x equals to L, and L is a real number. We have the same real number L for the left side limit over here and for the right side limit over here. So statement 2 and statement 3, both of them are correct because only these two statements are correct. Then we can have this statement, that is the limit x approaches a, ordinary limit x approaches a, f of x equals to L. Okay, now we have a big question. What about the statement 1, f of a equals to L? Is it correct or wrong? So like when left side limit and right side limit, both of them are equal to the same real number L, can I say that f of a equals to L or not? Actually, so we can have this statement f of a equals to L only if the given function is continuous at x equals to a. But here in the given question, we don't have any information about the continuity of the given function f of x at x equals to a. So and also some students may think, so both left side limit and right side limit when x approaches a are equal to the same real number L. Why can't the given function f of x be continuous at x equals to a? So only if the two limits, the left side limit and right side limit are equal to the same real number, then we cannot decide the function is continuous at x equals to a, because when x approaches, when x is getting closer and closer to a from its left side, and when x is getting closer and closer to a from its right side, in both the cases f of x approaches the same real number L. So it does not mean that the function is continuous at x equals to a. So because like when x equals to a, there may be a hole for the function, given function f of x. In that case, this f of a cannot be equal to L. So if there is a hole at x equals to a for the given function, so there may be a hole, but I'm not saying that definitely there is a hole. There may be a hole or there may not be a hole for f of x at x equals to a, but we don't have any clear information about the hole at x equals to a. So we cannot decide that the function is continuous at x equals to a. Maybe the function is continuous, but we don't have any clear information. Since we don't have any clear information, we cannot decide the function is continuous at x equals to a. In that case, we cannot decide that f of a equals to L. So the first statement cannot be considered as true because the information is not sufficient. So I'm pretty sure statement 2 and statement 3 are correct. So we find statement 2 and statement 3 are true in option D. So the correct answer choice for this question is option D.